Hi, grade 11 students. Our lesson today is about complex number. We're going to have many parts to finish this chapter because we have a lot of things to talk about. First of all, definition. A complex number is a number written in the form of z equal a plus ib. A and b are real numbers. However, I is equal root minus 1. What does it mean I equal root minus 1? We know that before, if you have x squared was equal, for example, to minus 4, we used to say it's impossible. The root does not exist in the real. However, we have created a new set called imaginary set, and that set is called complex number, where x now is what? Plus or minus radical, for example, in this example, radical minus 4. Radical minus 4, as we said, does not exist in real but exists in that set, and we said let I equal root minus 1. If I equal root minus 1, this radical minus 4 in that case can be written as radical minus 4 equal radical minus 1 times radical 4. This radical minus 1 is called I, so that's why it's of the form of I. Radical 4 is 2, so 2i. So every time you see you have the I, it means I have the square root of negative number, and every complex number is written of the form 2 plus ib. For example, 2 plus 3i. 2 is a real number, 3 is a real number, but I is a square root minus 1. We call A is the real set, B we call it the imaginary set. So as we said, when the power, even power, for example, is less than 0, it's not does not exist in real, but in a set called complex, and the abbreviation of the complex is C, that form. So let us go more. Properties, we said I is equal 1, which is root minus 1. I squared, if you square this square root, you get minus 1. So that's what I was saying. And you have a square number equal minus 1. I cube is I times I square. But since I square is minus 1 times I, so it will be minus I. So this is minus I. So I cube is minus I. And I power 4, so it's minus 1 square. So it's 1. From now and on, because if you continue I5, it will be a repetition I6, I7, I8, I9, I10, whatever. What do? If you have a power bigger than 4, you divide by 4. If the remainder of the division by 4 is 1, you get I1. If the remainder of division, like for example I6, I10, I14 is 2, it's I square minus 1. If the remainder of division is a 3, it's minus I. And if the remainder of the division is 0, it's divisible, so the answer is 1. So where we're going to use this one. Suppose you want to simplify here in this problem. 2 minus radical minus 5. You cannot keep in math radical minus 5 as it is. You must write it in I, or we can say it's impossible. But to tell me we're talking in complex, so you put I. So 2 minus radical minus 5, you write it as 2 minus I radical 5. 2 is the real part, and radical 5, which is the coefficient of I is the imaginary part. If you have radical 2 times radical minus 3, radical minus 2 is I radical 2, radical minus 3 is I radical 3, I times I is I square, but we know that I square is minus, so minus radical 6. If you have this distributive property, before we start distributing, we input the square negative by introducing I. So 2 minus I radical 5 into 2I radical 3 plus 2. Now if you start multiply, 2 times 2 is 4. I radical 3. 2 times 2 is 4. Minus I radical 5 times 2I radical 3. We multiply outside with outside. Minus 2 times 2I is minus 2I squared. Radical 5 times radical 3. Sorry, here it must be radical 15. And if we continue here, 5. And I radical 5 times 2, so it's minus 2I radical 5. But I square, we all know it's minus 1 from up. We said I is I square is minus 1, I cube is minus I, and I power 0 is 1, or power 4 is 1. So that's why we must here have plus 2 radical 10, because minus times minus is a plus. So to write it in the form of z equal a plus ib, we put first of all the things without I alone. This is the real part. This is A. and the one with the coefficient of I, B. So you're going to get 4 radical 3 minus 2I radical 5. More example, if you have a square, before you square, you put radical minus 5 as radical I radical 5. It's A minus B square. You square the first 4 minus 2AB. It means 2 times 2 times I radical 5. And you square this one, the last one. I squared times 5, so 5I squared. But we know that I squared is minus 1. So it's minus 5. 4 minus 5 is minus 1 minus 4I radical 5. The real part is minus 1 and the imaginary part is the coefficient of I, which is minus 4 radical 5. If we take this one, as I told you in this example here, if the remainder of division of by 4 is 1, it's I. If it's 2, it's minus 1. If it's 3, minus I. If no remainder, it's 1. So here, I11, if you divide 11 by 4, the remainder here is a 3. 16, if you divide it by 4, remainder is 0, no remainder divisible. 42, if you divide it by 4, remainder is 2. 83, remainder is a 3. I square is I square. And 22I is I, and 22 remainder 2. I cube is minus I. Minus I times 2 is minus 2I. It's minus 7. I power 0 is 1. I square is minus 1, so times 2 minus 2. I cube is minus I times minus 3 is plus 3I. I square is minus 1 times minus 2 is 2. Minus 3I, and I square is minus 1 minus 2. You add the things without I alone, it will be minus 9, and the things with the I, it will be minus 2I. Let us introduce the conjugate of a complex number. The conjugate, if z equal a plus ib, then the conjugate is denoted by z bar or z star. Sometimes they put star. You keep the real as it is, but you change the imaginary. So, for example, if you have 2 minus 3i, the conjugate of 2 minus 3i is 2 plus 3i. You keep the real as it is, only you change the imaginary. We're going to see why. We know from before that a minus b into a plus b is a square minus b square. If you multiply z by z bar, a complex number by its conjugate, if you apply this property, you're going to get a square minus I square b square. But I square is positive by minus 1. Minus times minus, so it will be plus. So a square minus b square from now and on is a complex number times its conjugate. So what's happening here? What's happening here, if you have a complex number times its conjugate, the answer will not be a complex, it will be a real number. It will be a 2 plus b2, which is a number, an ordinary number. So if you multiply, for example, 2 minus 3i by 2 plus 3i, so the answer will be 4 a square coefficient of the real part, you square it, plus coefficient of I is what here, 3. If you square it, it will be 9. So as you can see, a complex number times its conjugate is a real number. So in that case, if you want to get rid of the complex, you must multiply it by the conjugate. We're going to see where we're going to use it. Suppose I said in this example to factorize f of x. Factorize and then solve f of x equal to 0. To factorize it, you know that a square minus b square is a minus b into a plus b. If you equate it to 0, either this product is 0 or that product is 0. So x is 3, x equal minus 3. You know it from before, from elementary classes. But however, if you have x squared plus 9, I cannot use the property a minus b, a plus b. But I told you here, if a square plus b square, if I have plus, I can factorize and see in the complex. It will be a plus ib into a minus ib. So that's why if you have x squared plus 9, as you're doing x squared minus 9, but the difference, you put x minus 3i, you add the I, and you put x plus 3i. In that case, I factorize it in the complex. And if you want to solve it equal to 0, you take each factor 0. So x is a 3i or x equal minus 3i. We can do it in another method. You can say x squared equal minus 9. If x squared equal minus 9, we know this is impossible in real, but it exists in complex. So x will be plus or minus radical minus 9. But we know that the minus is I, and radical 9 is a 3. So the answer will be 3i or minus 3i. So anytime you have a2 plus b2, it's a minus ib into a plus ib. Let us go more. Suppose I want to factorize that one. It's of the form a2 plus b2. It's a minus